So we're going to keep talking about integrating. The integrating we're talking about is going to continue to involve inverse trig functions. So what we need to talk about are two separate things. Rewriting first as the sum of two quotients, and then using completing the square to help us integrate. To try to make the videos shorter, because I know they've been getting long with these longer process, with the longer process that we've been looking at. I'm going to break it into two videos. So this first one is just going to be rewriting as the sum of two quotients. Because I know that I'm going to still be a lot of times involving inverse trig functions, I just wrote out my inverse trig functions here. So looking at this first example, and there are two examples on this video, I would first look, so if you remember on the last video I kept saying, if I try to use u substitution, it doesn't work. Well, if I try to use u substitution here, I know that if I made u 4 minus x squared, du would be 2x. I have the x, I don't have the 2. But unfortunately, I have like this nasty plus 2 that's just going to get in the way and isn't going to do anything for me. And I know that I can use u substitution again because of the x. Notice that in all of these formulas, I do not have a variable on top. So that's also kind of why I know that I'm not quite ready to use an inverse trig function. So because this 2, I'm anticipating that getting in the way, I'm going to go ahead and rewrite this as a sum of two quotients, giving me the integral of x over the square root of 4 minus x squared dx plus the integral of 2 over the square root of 4 minus x squared dx. So now from here I'm going to have to integrate each individually and then I can add them together. So I already kind of talked about how on this first one I'm probably going to want to use u substitution. So I'm going to kind of write my work off to the left here so it's not going to be directly under it, but I'm going to let u equal 4 minus x squared and then du dx equals negative 2x. So du equals negative 2x dx. Okay. Well, I have the x. And I have the dx. I don't have the negative 2. So I'm going to go ahead and fix that by putting a negative 1/2 out front and a negative 2 right here. Now I have the negative 2x dx to put du in for. I can replace this with u. Over on this one, I noticed that I could pull that 2 out front, and I could let a be 2, u be x, because once I pull that 2 out front, I'm looking a lot more like one of these trig functions. Specifically, I'm looking like arc sine of u. I'm looking like this one, which would integrate to be arc sine. So a is 2, u is x, du would just be dx. So rewriting each of these, I get negative 1/2 times the integral of 1 over u to the 1/2 du plus 2 times the integral of du over the square root of a squared minus u squared. Well, 1 over u to the 1/2 is the exact same thing as the integral of u to the negative 1/2. So if this is u to the negative 1/2, I'm going to end up with negative 1/2 times 1 over 1 plus negative 1/2, which will be 1/2. I'm going to go ahead and just write it as 1/2. U to the 1 plus negative 1/2, which is 1/2. I'm going to hold off and put my c at the very end. That one looks weird. Plus 2 times, this becomes arc sine of u over a, and then all plus c. So I only have to have one c if I have two integrals. Well, this 1/2 on the bottom is going to come up and be 2 over 1. So I'll have negative 1/2 times 2 over 1, which is going to give me a negative u, which remember was 4 minus x squared to the 1/2 plus 2 arc sine of u being, up here, so I used a different u for this piece. U is x, a is 2, so x over 2 plus c, and I have successfully integrated after first separating my fraction. And just to point out, because I get this question a lot from you guys sometimes, is that the reason I could separate this is because how do I add two fractions? Well, don't I combine the tops and keep the same denominator? So that's kind of why I was able to separate it, because sometimes I see you guys want to separate the bottom. Can't separate the bottom, just top. So moving on to example 2. I'm going to do kind of the same thing with example 2, because again I have my, trig functions just written up here, or the integrals that I get inverse trig functions with. So looking at this, if I let u equal 1 minus x squared, which usually was causing a problem in the last video, in this video I know that's going to integrate or differentiate to be negative 2x. I have the x. I can easily get rid of the 4 by bringing it out front and getting the negative 2 in there. This 3 again is going to cause a problem. So I'm going to try to separate it similar to the way I did on the last one, giving me the integral of 4x over the square root of 1 minus x squared dx plus the integral of 3 over the square root of 1 minus x squared dx. And when I go to integrate this, I already made note that on the first one, I'm going to have to probably use u substitution. So I'm going to let u equal 1 minus x squared, which means du will be negative 2x dx, because du over dx would be negative 2x. I kind of combined a step there. Du would be then negative 2x dx. So I don't have 2, I have 4. I need negative 2. So wouldn't this 4 change if I pulled out a 2 and made it negative? So I'm going to do that in my next step. I noticed then I could also take this 3 and bring it out to the front, because again, none of these have a constant on top. So rewriting just a little bit, that 4 I'm going to take and make it negative 2. So in order to change that from 4 to 2, I'm going to take 2 out, and then I have 2 left, but I want it to be negative, so I'm going to make it negative by also making this negative. Taking the 3 out. Okay. So now from here, I'm able to actually go ahead and do my u substitution. I have my negative 2x dx, so I have my du. I can place this in here, giving me then the square root of u on the bottom. Over here on the right integral, I notice that it's very similar to arc sine again. So I can let a be 1, and I can let u be x. And then du will just be dx, since the derivative of x is just 1. So then going ahead and actually plugging some stuff in, I will have negative 2 times the integral of 1 over u to the 1/2 du plus 3 times the integral of du over the square root of a squared minus u squared. So going ahead, and I'm actually, on this one, since I have a little bit more room than I did on the last one, I'll rewrite u as u to the negative 1/2 rather than having to keep saying it. Okay, so now if I go ahead and integrate, I end up with negative 2 times 1 over negative 1/2 plus 1, which is 1 over 1/2, u to the negative 1/2 plus 1, plus 3. This becomes arc sine of u over a plus c. Cleaning up a little bit. Negative 2 times 1 over 1/2 is negative 2 times 2 over 1, which becomes negative 4 times u, which I remember made 1 minus x squared for my first integral, to the 1/2, plus 3 arc sine of u. U on the second integral was x. A was 1, so I'm just going to go ahead and say x. I don't have to say x over 1, plus c. And now I have correctly integrated this again by first separating my my fraction. So the next video is going to talk about how you can use completing the square to help you with integrating, and that also is going to tie in some inverse trig functions.